In this video, we are going to see the communication model behind the modern networks and the internet, which is the TCP/IP model. TCP/IP was designed and developed by the Department of Defense in the 1960s. It stands for Transmission Control Protocol, Internet Protocol. TCP and IP are different protocols of the computer networks that we already know. IP finds, that is Internet Protocol, finds the destination of the mail or a message, and the TCP has the work to send and receive the mail or message. And the TCP/IP model is a concise version of this OSI model. Unlike the OSI model, which has 7 layers, this TCP/IP model has 4 layers. And the TCP/IP model became the standard for modern networks and is the model that we all use now on the modern internet. So this is the base model for in communication in the internet. And OSI model is used only in academic purposes and as a reference model. Now we will be understanding the difference between the TCP/IP model and the OSI model. This TCP/IP model is only used in this modern world and those modern networks and the internet. TCP/IP protocol suite in the sense communication between computers on the network is done through this protocol suites. That is most widely used and most widely available protocol suite is the TCP/IP protocol suite. This TCP protocol suite consists of a layered architecture where each layer depicts some functionality which can be carried out by a particular protocol. And this TCP/IP is normally considered to be a 4-layered system. We already said that it consists of 4 layers: application layer, transport layer, network layer, data link layer. And now we can see them one by one. Application layer, that is this TCP/IP model of communication follows a 4-layered approach. First one is the application layer. This is the top layer of TCP/IP protocol suite. This includes the applications that use the transport layer protocols to deliver the data to the destination computers. This application layer also has various protocols that applications use to communicate with the transport layer. This has various protocols. They are the hypertext transfer protocol, file transfer protocol, SMTP, that is simple mail transfer protocol, this simple network management protocol. These are the protocols that are used by this application layer to communicate with the transport layer, which is the second layer. Coming to the transport layer, which provides the backbone for the data flow. This layer receives data from the application layer above it. That is, it is the second layer that receives data from the application layer. In this TCP/IP protocol suite, the two most commonly used protocols at this transport layer are TCP and UDP, that is Transmission Control Protocol and User Datagram Protocol. If you are a beginner, you can check my video on what is a protocol. That's a set of rules. You can check my video on that. And TCP is used where a reliable connection is required. Reliable in the sense loss of data is not acceptable. And UDP provides a simpler but unreliable service by sending packets from one host to another. This unreliable in the sense the data loss can be acceptable. While streaming a video, we can accept some loss. It will not be of much loss to the user. So that is the difference between reliable and unreliable service. This TCP provides a reliable connection. This divides this TCP divides the data into proper size chunks and passes these chunks to the network. This waits for acknowledgements of the packet sent and sets a timeout to resend the packet if the acknowledgements are not received. So this in such a way, this TCP provides a reliable connection. But DODP does not take any extra measure to ensure that the data sent is received by the target host or not. So this is the difference between these two. And coming to the network layer, this is also known as the internet layer. The main purpose of this layer is to organize or handle the movement of data on the network. And movement of data mean routing of data over the network. The main protocol used at this layer is the internet protocol. And the last layer is the data link layer, and this layer is also known as the network interface layer. This normally consists of device drivers in the OS and the network interface card attached to the system. Both of them take care of the communication details with the media being transferred to the data to use to transfer the data. In most cases, this media is in the form of cables. So some famous protocols used in this layer are address resolution protocol and point-to-point protocol. And now we can see with this TCP/IP concept with an example. We can see the interaction between computers over the network through the TCP/IP protocol suite that takes place in the form of client-server architecture. That is, this TCP/IP model works in the form of a client-server architecture. Here the client requests for a service while the server processes the request for the client. In this example, we can consider data flow when you open a website in your laptop. The target web server where the website is stored is contacted here, and through the TCP/IP model of communication. For the first layer, since the HTTP protocol is being used, so a HTTP request is formed and sent to the transport layer, requesting the target web page which is stored at the web server. So as we already said, in the application layer, HTTP protocol is used. Here the protocol TCP assigns and then the TCP assigns some more information like sequence number, source port number, destination port number, etc. to the data coming from the upper layer, that is the application layer, so that the communication remains reliable. That is, a track of sent data and received data could be maintained. So this is done by the transport layer by the TCP protocol. And then at the next lower layer, the IP adds its own information over the data coming from the transport layer. This information would help in the packet traveling over the network. Lastly, the data link layer makes sure that the data transfer to or from the physical media is done properly. Here again, the communication is done at the data link layer can be reliable or unreliable. Now the information traveled has crossed the 4 layers of communication in this model, and this travels on the physical media like Ethernet and reaches the target machine. Now in this case, the target machine is the web server that hosts the web page, and the same series of interactions will happen but in the reverse order. Now the packet is first received at the data link layer. At this layer, the information that was stuffed by the data link layer protocol of the host machine is read, and the rest of the data is passed to the upper layer. So data link layer reads the host machine's data link layer data, and then it passes the rest of the data and to the upper layer, that is the network layer. And the information set by the network layer of the is in the host machine is read, and the rest of the information is passed to the upper layer. The same happens at the transport layer also, and finally the HTTP request sent by the host application is received by the target application, that is the web server. And Now we are saying that the information sent is crossing the four layers of this model, and one can wonder what happens when information particular to each layer is read by the corresponding protocols at the target machine also, and why it is required. So to explain that, for example, at the host machine, the TCP protocol present at the transport layer adds information like the sequence number to each packet sent by this layer. And at the target machine, when the packet reaches at this same layer, the TCP at this layer makes note of the sequence number of the packet and sends an acknowledgement. Now, if the host TCP does not receive the acknowledgement, that is the sender does host that is the sender's TCP does not receive the acknowledgement within the specified time, it resends the same packet. So this way the TCP makes sure that no packet gets lost. So we see that protocol at every layer reads the information set by its counterpart to achieve the functionality of the layer it represents. So now you will be clearly understanding the model of TCP IP. Subscribe to my channel if you feel contented. Like and share my videos with your friends.